Howdy, it's Mr. Pete again, your YouTube shop teacher, and this is part 9 of the rather relentless build here on the AMF float lock mini vise, drill press vise. So I'm continuing on that, and then in part 10 I will do the finishing work and the final assembly. But in this episode I plan on making the clamp that mounts on the corner mount that I did in a previous video. So this is what I'm going to do today. And I think before even explaining how this works, I'm just going to go ahead and make this screw. I'm not going to use hexagon, and I'm not going to make it two pieces. This is two pieces. This is hex stock with a bolt pin to it. I'm going to make it out of 3/4, turn it down to 3/8, and thread it. I'm going to rush through that real quickly, and the dimensions are approximately what we have here, with about at least a 1/2 inch sticking out. That's probably almost 3/4, and that's not too critical. Allow for a washer in here, and the head doesn't need to be quite that long. Okay, 3/4 inch cold rolled stock, 1.5 inch mark. I'm going to take it down to 3/8 in several passes, and I have a carriage stop set, and you cannot see that. Now, several things. You saw me square off the shoulder with a cut-off tool because I had quite a radius on that turning tool. I've marked it at 3/4 inch, and that's how much thread I'm going to put on there. I have a 3/8/16 die in the die holder held in a Jacob's chuck in the tail stock. I get a nice chamfer on there, and I always like to turn it down just a little bit undersize for threading. It saves a little bit of a problem, because you don't need a full depth thread for something like this anyway, and it'll still be a 70% depth thread, and I will run it in back ears at slow speed. I have the work clamped in the Heinrich cross hole jig, and that's a 3/16 bushing, so that'll give me a perfect cross hole that is centered and doesn't come out the side. I actually want a 13/64 hole, and since I do not have a bushing that size, I'll take this drill out, take the bushing out, and even though I don't have a bushing that size, I have not removed the work, and it will stay on center, and I still will get a good hole. And I'm just opening it up 1/64. And a perfect cross hole. Now all I got to do is cut it off. Notice that I did not cut it off up until this point, or there isn't enough to hold in the lathe chuck, or for that matter this jig. Now, rather than make a new handle, I'm going to use the one out of the prototype. You've seen me make this kind of handle many times. This particular one is nothing more than 3/16 rod. It's been threaded on both ends just a little bit, and 3/16, that would be 10/24 nuts, put on with Loctite. And I was able to remove one just by wrapping emery cloth around it with a plier, and then I'll tighten that up again. And that's all there's to it. Now, if I need a larger handle, that is 1/4 inch diameter instead of 3/16, I can make one if this is not up to the task. But that's what it looks like. I know I rushed through that real fast, but it's pretty routine work. And this is 2.5 inches long, again, and 3/16 diameter, 10/24. I know I repeated that, but it bears repeating. Alright, that's done. Let's get on to the hard part. Alright, I'm done with the bolt, and it's time to turn my attention to the lock, the two-piece lock, which I'll be making out of steel, not aluminum. But let's take a look at something here first. And when I lay this on a flat surface here, and you want to check yours as well, we want to make sure that the rod here is pretty close to parallel with the surface plate. Now you're probably not going to get it perfect, but by using a drill bit or a adjustable parallel, you should check that the distance here is about the same as it is out here, and there is just a little bit of drag when I start to get in this area here, so it's not perfect, but it's it's going to probably be as good as it needs to be, because after all, this is just a vise. Now you have to make this lock accurately enough such that as you tighten it, it truly does lock the vise down and it doesn't lift it up. We do not want the vise to lift up off the table when we tighten it. In fact, we want the vise to get pushed down. I'm going to talk a lot more about that later on, but if you slide a piece of paper under there, like that, and then lock this, the paper should be tight, like that. If you look at the original lock on float lock vices, you will see that there is cast in an arrow right here, like that. That arrow should always point toward the operator. And in fact, I had a heck of a time at the high school because the kids would put it on there any old way, however it happened to go on. And if the arrow was in the opposite direction, you could be assured that it would lift the vise off the table. So there was an angle milled onto this. Now, I'm not going to do that right away in the initial one, and I probably won't do it at all, but there is the possibility that I will do that. And again, the purpose of that is to lock it down, hence the name, float lock. This piece is tricky, and there is more than one way to make it. And originally, if you watch that very first video that I did on what is a float lock vise, I made it out of wood, out of maple, and then I graduated to aluminum, and now I'm going to graduate to steel. Do you remember where I got this piece? Yeah, that was the extra piece that was left between the two jaws on the original piece. So that's almost exactly the size that I want. Isn't that a coincidence? And it's the right width, virtually, and a little bit higher, but no problem, because there's going to be some milling done in here. So that's going to be just perfect to make this lock out of. Well, I put some layout dye on this thing, but I believe the first thing I'll do off camera is these are just rough sawn ends, and I'm going to go over to the mill and mill those off so that it's square, and it looks a little better. And the dimension is very uncritical. In fact, what is the dimension here? Well, on the aluminum one here, it is just a little under 2. Here I'm a little over 2, so it'd be nice to mill it down to approximately 2 inches. All right, 1/2 inch by 1/2 inch. Center punch and drill a 3/8 hole and deburr. I'll do that off camera. Don't be surprised if you don't have to make 2 or 3 of these. So make a mock-up if you have to. But let's establish a dimension here. Remember, this piece is 3/16 thick. And how thick should this be? But also remember, I've milled some off of this so that it would clamp by laying that on there and laying a 1/2 inch punch on there, which has a center on it. The height really is, I got a height gauge here, is 5/8 of an inch. Alright, that's just a target dimension. Now you may be using the drawing that Ken made, and that's great, instead of this method here. But also looking at this, when I have it clamped on a piece of 1/2 inch material here, remember that this doesn't lay flat. I've removed some material so that when we put the bolt in here, it will clamp. Otherwise, this would pull out freely. So that has to be taken into consideration as well. So this dimension from the bottom up is about 417, but I want to allow more than that. I'm going to allow about 440. So I'm going to set my height gauge for 440 and scribe it. And this hole is 5/8 from the end. And I will center punch this. And this line is going to serve not only as a layout for this hole, but that's also our saw line. We're going to eventually saw the piece in two along that line. Alright, off camera I'm going to drill this hole 3/8. Well, why not 1/2 inch, you're saying? There can't be anybody in the entire free world that's following this. I barely understand it myself. But anyway, I'm going to drill that 3/8 because later on, after it's sawed apart, I will have to re-drill it again 1/2 inch. So I need some allowance for that. 3/8 or thereabout. Could be 7/16, I suppose. Alright, now I'm going to saw it in two on this line. I'm going to try to saw as straight as possible. If you wander off the line, remember we have to come back and clean this up on the milling machine. We don't want to lose too much stock. We're already losing some with the kerf. Okay, I hope you got a bandsaw. You sure don't want to do that by hand, but there it is, cut into two pieces, and it's still almost too hot to touch. That took 10 minutes on the bandsaw almost. Well, if you don't have a bandsaw, another way of doing this, and it probably even is a better way, to start with two separate pieces and drill the hole as such, like that, because these sides could have been milled to a dimension. So that's a consideration too. Matter of fact, that's probably far better than the way I'm doing it. Well, as always, I've told you there's so many different ways of doing things, 100 different ways. So do it however you want. Now, off camera, I'm going to go over to the milling machine and I'm going to mill this surface and this surface, and I'm going to take off as little as possible, just enough to clean it up. Be right back. Alright, they're milled off, and it didn't quite clean up, but it couldn't matter less, and you'll see why in a minute. So now I'm ready to drill this hole, but now the hole is no longer round, it's an oval hole, an ellipse. But I'm taking a dowel pin. You could use any old 3/8 rod, and I didn't want to tell you this before, but that's why I drilled this hole first, is that will hold it in alignment while I drill that, because it's going to be kind of a rat-tat-tat-tat-tat as I try to make a round hole out of that again. So that will be, what did I say, 1/2 inch. Be nice to ream it. Maybe I will ream it, but maybe not necessary. No, I'm just going to drill it. You know what? I decided to drill it 3/8. That brought it back into round. That's already done. And I have a 1/2 inch bit in here now, and I'm just going to drill it 1/2 inch. And it's now a round hole, so it's not going to grab. I hope. Peterson Products Vise. Looking good. Now, of course, it's not going to clamp down at this point. This is a 1/2 inch rod. So I will take it back to the mill off camera, and I think I'll take off 5/1000ths off of this surface and 5/1000ths off of this surface, or 4. I guess it isn't too critical. I'm not sure what I've got on this one, but it needs to do this. I took about 3 or 4/1000ths off of each one, so you can see it's going to clamp now. One more thing to do. Alright, look carefully. Now as I tighten up the clamp, I've got a piece of paper under here. You can see that it's not tight. So I have to remove something off of the an undetermined amount off the bottom part of the clamp. I'm not sure how much, so I have to measure. Okay, there's one more short milling job, but I have to determine a dimension. Now, I know that this is correct, but I made that several weeks ago by Vise and Bagosh and finally determined what the thickness should be right here. And that is very critical. I'll show you why in just a second. But at this point, this dimension right here on the steel piece is quite a bit more. So laying the two of them side by side like this, with a 1/2 inch rod in there, you can see that quite a bit has to be milled off of the bottom now. Not the top, but this surface right here, I better mark it, is what has to be milled off, and I have to determine how much. Now let's go overlay that on the drill press and review this again. I'm actually going to say the same thing again. Perhaps you can see that with this piece I cannot get it up on the corner clamp, and when I pull it off you can see that it's too thick. Watch this drop. Or put another way, you can see that even if I tighten this, it's not pushed down on the table, the drill press table. Alright, about a half hour has passed and I'm struggling here a little bit, and I ran into a problem, one of which is I had this hole out a little bit too far away from this rod, so it wasn't compressing the way I wanted to, so I drilled another hole, and there was room in there for that, but I would change that dimension a little bit if you look at that. See, there was room in there. So overall this piece could be made a little bit shorter, and probably this hole moved someplace in between the two holes would be fine. But it's clamping quite nicely now, so that does solve the problem. I am not going to make a new one. Okay, still one more thing to do. And again, the bottom part of the clamp is a little too thick, so I have to mill some off. So how am I determining that other than Vise and Bagosh? I've taken an adjustable parallel and measured that height, and it's 0.398. And then I also did it down at the other end here. And I've got 388, so there's really 10 thousandths difference. So I'm going to take 10 thousandths off of that. Now you can also do that if you don't have one of these parallels. Use drill bits, and that's going to get you close enough probably. Gauge blocks would be overkill. So I will take it apart one last time, and I'm going to mill 10 thousandths off of the bottom of this piece. Well, that didn't take long. Let's see how it fits. That's better. And what I'm concerned with is this, does the vise get pushed down toward the table? And it does. So I'm satisfied. We don't want it to lift up as we tighten. We want it to go down. And that's what that arrow was all about that I talked about a little bit earlier. And I'm not going to go into that because I doubt if anybody wants to carry it out that far. But there would have to be an angle, as far as I know, milled on the bottom of this bottom piece that would pull it down in that position. As far as I know, all of the more expensive float lock vices had that arrow. I do not know if this one did, the cheaper one, because I did not get that piece. It was missing at the auction when I bought the vise, the yellow vise. I probably will remake this part at my leisure, but for now I'm stuck with an extra hole. Now, if you do not feel like making this part, you can save yourself an hour's work by simply using a cap screw and put a box end wrench on there. As a matter of fact, you'll get more leverage probably than what you will with this. This possibly could use a little bit longer handle. Well, that completes this video and really completes the vise, except in part 10, I'm going to take it apart, clean it up real good, probably put bluing on it, paint some of the surfaces, pretty much like what you see with this, and then do the final assembly as far as driving the roll pins, tension pins into place for final assembly and to complete the job. This has been a long video series. This completes part 9. I'll see you in part 10. This is tubalcain.